Welcome to our lesson on solving special systems. First, before we get into any examples, I want to define a couple words for you. We have what are called consistent systems, which are systems with at least one solution. And then we have inconsistent systems, which are systems with no solutions. So we're going to first look at an example, and we're going to decide if this system is consistent or if it's inconsistent. So here in example 1, we need to show that the following system has no solutions. So we're going to show why it would be inconsistent. This system is going to be composed of the equations y equals x minus 1 and negative x plus y equals 2. Now, from our previous videos, we learned that if we have at least one equation solved for one variable, we can use the substitution method. So let's do that. I'm going to replace y in the second equation with x minus 1. So I'm going to have negative x plus x minus 1 equals 2. Well, if I combine like terms, a negative x and an x, they're going to cancel each other out. They're going to make 0x. And we're going to get negative 1 equals 2, which is not true. That's a false statement. So here, this is where we can say this system has no solution. We also could have put both equations into slope-intercept form. Remember, that's y equals mx plus b form, which the first one's already there. If we were going to do that for the second one, we would need to add an x, and we would have y equals x plus 2. And if we look at both equations, y equals x plus 2 and y equals x minus 1, the slope of each line, the number that's in front of x, is 1 for both of them, which means the two lines are parallel, which means they'll never cross. So if we graphed this system, another method, we would find that they never ever cross, and if lines never cross, then the system that represents these two lines cannot have a solution. Let's look at another example. So this one we will call example 2. We are going to show that the system has infinite solutions, meaning any number you plug in for x and y will give you the same answer. So the system is going to be represented by the equations y equals 2x plus 1 and 2x minus y plus 1 equals 0. Now, we could compare the slopes, so put them both into slope-intercept form, which the first equation already is. It's y equals 2x plus 1. The second one, if we add y to both sides, we'll get y equals 2x plus 1 as well. Well, the lines are the same. So if the equations are the same, that means the lines are the same, which means every x value we plug in is going to give the same y value. we could call that method 1. We can call it compare slopes. Method 2, just like in our last example, we could, since one of these equations is in slope-intercept form or solved for one variable, we could substitute it into the other equation. We could write 2x minus 2x plus 1 plus 1 equals 0. Wherever there was a y in our second equation, we replaced it with 2x plus 1. Well, now we can distribute this minus sign, so we're going to have 2x minus 2x minus 1 plus 1 equals 0. Well, the 2x's, they're going to cancel each other out, and the 1's are going to cancel each other out, so we are going to get 0 equals 0, which is a true statement. If this happens, we can say that we have infinite solutions, meaning all numbers, all real numbers, are able to be plugged in and give us a solution. I have a little bit more we need to talk about in this video before we move on. So within our consistent systems, there's two other types of systems we can have. We can have an independent system, and if a system is independent, the system has exactly one solution. And then we can also have a dependent system. And if we have a dependent system, then the system has infinite solutions. Now, if we were looking at the graph of an independent system, so I'm going to make a little space here and I'm going to give you some picture examples. The graph of an independent solution or independent system, if we have our xy coordinate plane, two lines would make up an independent system if they cross at only one spot. This would be an independent and consistent system. If we have a dependent system, which means it's also consistent, we have our xy axis, we're going to graph both lines and they're actually going to fall in the exact same spot, which means the two lines are the exact same line. So let's move on. Let's look at another example. We're going to classify the system as inconsistent or consistent, and if it is consistent, we're going to define it as independent or dependent. So example 3, we're going to classify each system. We're going to look at two of them, and then give the number of solutions. So we're going to decide, if it is consistent, does it have one or infinite solutions? So we'll look at example 3a first. We're going to have the system 2y equals x plus 2 and negative 1/2 x plus y is equal to 1. So what we're going to do is we are going to solve this. Well, what we could do is we could put both lines in slope-intercept form. Solve them both for y. In the first equation, the 2y equals x plus 2, we can divide every term by 2, and we're going to get y equals 1/2 x plus 1. And then in the second equation, I'm going to write that one here in blue, in the negative 1/2 x plus y equals 1. We're going to add the 1/2 x to both sides. And from there, we're going to find that we get y equals 1/2 x plus 1. Well, these two equations are the exact same. If the two lines are the exact same, then we have a consistent system. So we can write that this system is consistent and it has infinite solutions. Pretty neat. Let's look at another system. We'll call this example 3b, that I'll do here in red, where the system is y equals 2 times the quantity x minus 1 and y equals x plus 1. So with this first one, let's start first by distributing our 2x. Get rid of any parentheses. We're going to have y equals 2x minus 1 and y equals x plus 1. We're just rewriting the system. Now, what I notice is the lines are not the same, but they do have different slopes. The numbers that are in front of x, we've got a 2, and then in the second equation there is technically a 1 there. Since they have different slopes, they are going to intersect, which means that this system is consistent. If they cross each other, then they are consistent. And because they only cross at one point, because they're different lines with different slopes, there is one solution. So we can say has one solution. And that wraps up example 3. That actually is going to wrap up our whole lesson on solving special systems.